What up, YouTube? Welcome back to my channel. It's your boy J Dub, coming to you with another math problem. 2015, problem 5, page 18. And yeah, there's nothing else to be said. Let's get straight to it. Problem 5 says, let R be the region in the first quadrant enclosed by the graphs of g of x equals x to the square root and h of x equals x over 3. As shown in the figure above, A says find the area of region R. So it's a basic area problem. So first thing you want to do is find the area. So you want to do, as you can see on the graph above, what you want to do is do the top equation, which is the g of x equation, minus the bottom equation, which is the h of x equation. So what you want to do is, and it's going from 0 to 9, as we can see, because the x value here is 9. So what you want to do is you want to go integral from 0 to 9, g of x minus h of x dx. Now, me personally, I just like writing the writing the whole equation out. So I'm gonna do that for myself. All right, so right there, that's plus 1 point right there. We're just writing the integral. And now you have to solve it. So now you're gonna find the antiderivative, oh my God, which is gonna be 2 over 3x to the 3/2 power minus 1 over 6 x squared from 0 to 9. That's another point. We're just finding the antiderivative. And then after that, you're gonna solve it. So then that's gonna give you, you're gonna plug in 9 first for x. We won't act like that's a parentheses. Then you're gonna go minus, then you're gonna plug in 0. And then we're gonna simplify that down. This part is gonna simplify down to 18 minus 27 over 2. And this is going to subtract 2. Simplifying down to 0 minus 0. And then we're going to get 9/2 when that part simplifies down, minus 0. And then that's going to obviously simplify down to the area being 9/2. And then you're going to get a point for getting this answer. Now on to part B of the equation. Make sure y'all can see that. All right, it says, part B says, write but do not evaluate an expression involving one or more integrals that gives the volume of the solid generated when R is resolved about the horizontal line y equals 4. So all we gotta do is find the volume of this while it's being rotated around 4. And it's pretty simple. First thing you wanna do, first I'll write volume. And then we're gonna go pi. And then we're gonna go from the integral of 0 to 9. And since it's being rotated around, and then since it's being rotated around 4, which is this the part I left out on before the video stopped, we're gonna go 4 as the first number minus the top. And the top in this case is h over x. And then we're gonna close that parentheses and we're gonna square it. Minus, same thing, 4 minus the bottom, which is g of x. Close the parentheses, squared, dx. And for me, you know how I like, writing the whole equation in. So we're gonna go pi from the integral 0 to 9, bracket, parentheses, 4 minus x over 3, close the parentheses, squared, minus parentheses 4 minus x to the square root, close the parentheses, squared, close the bracket, dx. That is a mouthful, but this gets you 2 points. And your other 1 point, that does not look like a 2. Oh my God. Your other 1 point comes from your limits and your constants. So it would be this and pi. Now for C. Okay, so stop the video. So just in case we want to stop and delete the video again, so I wouldn't have to redo this for a third time because that would be tragic. So let's get straight to it. Part C asks, find the maximum vertical distance between the graph of G and the graph of H between x equals 0 and x equals 16. Justify your answer. Okay, so this problem, it's a lot going on. That's all I'm gonna say basically. So stick with me. We're gonna start with the equation for dx. And dx is your basic top minus bottom. And same thing. So therefore dx equals x to the square root minus x over 3. And yeah, I just wrote it like this to help myself, find the derivative, because you will need to do it in this problem. So I wrote x to the 1/2 minus 1/3 of x. So then now you need to find the derivative of dx. And that derivative will be 1/2 x to the negative 1/2 power minus 1 over 3. Now we need to find the value of x, because we already have 0, we already have 16, but we need to have a number in between that, to help us to get our third number basically. So we're gonna plug 0 in for dx. We're gonna set, 0 equals 1/2 x negative 1/2 to the negative 1/2 power minus 1 over 3. And then you're gonna solve this for x. I'm just gonna show y'all the work because I worked hard on this. So we're gonna get 1/3 equals 1/2 x minus to the negative 1/2 power. And then I'm gonna divide that by 1/2, and that's gonna give us 2 to the 3rd power equals x to the negative 1/2 power. And then we're gonna simplify some more. And we're gonna square root 2/3 to the negative root. And that's gonna give us x equals 9/4. You get 1 point for finding 9/4. So 1 point. I'm sorry, I'm trying to look at my notes, what I did. So yeah, and then I missed another point. You get another point for finding the derivative and setting it equal to 0. Okay, now all you need to do is justify your answer. And to justify your answer, I know we do it a different way in class, but this is how I do it on my own too. I do it just like the way that they do it. So for this, we're gonna give ourselves a little chart. This is the easiest way to do it to me, in my opinion. So, and on the sheet it says the distance between the graphs, but the distance between the graphs is the same thing as dx. But the only difference is it can't be any negative numbers when you're finding distance. So I just write in brackets dx, just to remind myself that it can't be any negative numbers. So we have here, we got x to 0, x is equal to 0, and we have x is equal to 16. So our three numbers are 0, 9/4, and 16. And when we plug 0 into the D equation, we're gonna get square root of 0 minus 0/3, and that'll come out to be 0. So this is 0. Then we plug 9/4 into the equation. We're gonna get square root of 9/4 minus 9/4/3, and that's gonna give us 3/4. And then when we plug 16 in, it's gonna give us the square root of 16 minus 16/3, which is gonna give us the answer of 4/3. I didn't even write these. So that's 3/4, and this will be 4/3, but it'll be negative 4/3. My bad. This is negative 4/3. Okay. So now for this, since it's the absolute value of the dx equation, we're just gonna write everything, but not in the negative number. We have to make it positive. So this will be 0. This will be 3/4, and this will be 4/3. And then you're gonna write your justification. Hopefully I got enough space to write it. Well, all right, YouTube, we're back for how many times is this? 5, 4, 6, I don't know. Somebody called me, so that stopped the video. So now we were back at our justification. And the justification is the last point in this problem. So my justification I wrote, and there's many ways to write this, but as long as you have the key points in, it's fine. I wrote the maximum verb. I just write in short terms, so I'll say the whole word, but you know, the maximum vertical distance from graph G to graph H from x equals 0 to x equals 16 is 4/3. And this is the last point for that problem. 3 points in total. So now, yeah, that's problem 5. Pretty sure I'm over 10 minutes with all the stoppages and technical difficulties I had. My bad, but J-Dub out.